Hi everyone, glad to make this presentation at the 33rd Canadian Conference on Artificial Intelligence. The topic of this presentation is using topic modeling to improve prediction of financial report commentary classes. I will follow this outline: introduction, problem and proposed solution, methodology, experiments and results, and conclusion. In any company, financial reports are generated from various transactions. They are then used to understand the discrepancies between actual performance and financial forecast. These reports are generated from different sources, including the daily sales transactions, inventories, cash flows, and supplier transactions. Financial analysts within the company examine the variances between projected outcomes and the actuals in certain time intervals, for example, weekly, monthly, or quarterly, and then provide management with insights. Accordingly, it is determined whether some adjustments are needed to be made to the targets or some other actions are needed to be taken in various departments to meet these targets. The analyst report usually involves a summary information that relates each variance with a short commentary that serves as a baseline for top management to take immediate actions. While this process relies on the analyst's knowledge of the business areas, the data coming from different areas of the company might lead to erroneous assessments. As such, there is a need to learn from existing commentaries and build a prediction model that helps the automatic generation of the commentaries and their associated classes. In previous works, we tried to predict the commentaries using an encoder-decoder structures that predict jointly from the variance dataset and the expert commentaries. However, the reduced set of commentaries and high variety among commentaries in terms of writing and wording made it hard to predict meaningful commentaries. Later, we simplified the problem and aimed to predict the category of the commentary rather than trying to generate the original text. Our analysis with various machine learning models, including support vector machines, random forests, and recurrent neural networks, indicated a positive predicted performance. While generating a commentary and its associated class is the task of an analyst, such manual operations might be erroneous and, as a result, might lead to a diminished performance for the employed prediction model due to wrong class labels. We propose applying topic modeling on the commentaries dataset in order to cluster commentaries based on their similarity and then predict the topic of the commentary rather than the full text. The model learns from the variance dataset and predicts the topic, which helps automating the overall process. The proposed approach is latent Drichlet allocation, or LDA. In the methodology part, data is provided by our partner company in two datasets that include 34 months from January 2016 to October 2018. The first dataset, denoted VAR, shown on this table, includes the difference between forecasts and actuals in millions of dollars for every customer and brand. The second dataset, denoted COM, is shown here contains the commentaries written by the analyst for every customer and brand. The analyst labels each commentary with one of the following labels: promo, phasing, POS, and other. Other corresponds to rare topics. The fifth label is no com and is associated with a brand and variance where no commentary is provided. This process has some issues. It leads to an imbalanced dataset having no com as majority class and other as a minority class. We apply undersampling of no com and oversampling for remaining classes to balance the label's occurrences. We process the VAR dataset in a way that every commentary emitted for a customer and a brand in any given month, we associate a time series of variance. I recall that variance is forecast minus actual. These variances are recorded for the customer and the brand for the preceding 12 months. So, the inputs is in the form of a vector of 13 elements that represent the variance for a brand-customer pair during the months M0, which is the current month, and the 12 preceding months, so M-1 back to M-12. The model is trained on the class of the commentary associated with the customer-brand pair. We pre-process all commentaries, converting to lowercase, removing punctuation, stop words, lemmatizing, and stemming. The comment after pre-processing is supposed to contain only useful keywords. Then we apply TF-IDF. Each commentary is then converted into a set of tokens associated with their TF-IDF scores. Finally, we apply LDA to all commentaries by using the three topics. The one with the highest probability is considered as the main topic of the commentary. It may happen that all words in a commentary are removed in the pre-processing phase. In this case, we associate a label general to the commentary. Consequently, LDA results in 5 labels equal in number to the labels provided by analysts but different in nature as they are produced by clustering using LDA. We train 5 models, each one is based on a different classification approach. Additionally, we consider feature selection based on random forest feature importance by keeping 4 months out of 13. The commentaries dataset contains 2,607 data points, where only 521 are associated with commentaries. The average number of words in a commentary is 9, and after pre-processing, this number is reduced to 4. Around 6% of the commentaries ended up being empty. So we carry on 3 different experiments. So the first one with analysts and LDA labels using 3 topics and no feature selection. In the second, we use 3 topics and with feature selection. The third one is with analyst LDA labels using 2 topics and with feature selection. We use a 80-20 test train test split. We run all models 25 times with random oversampling, downsampling, and we report the F1 scores. So this figure indicates that there is no significant improvement in the F1 score when learning with the original labels and the ones generated by LDA without feature selection. We note that after feature selection, results are improved for XGB and SPM. In this figure, we can see that with 2 topics, LDA-based models perform better than with the original labels. This can be explained by the fact that the number of labels with LDA is smaller. However, from a practical perspective, such results are still interesting for the consumer goods company, as the model is able to predict the commentary topic and provide insightful keywords for every topic. This last figure illustrates the distribution of each analyst label by LDA topic. If we discard the general topic, the figure does not reveal a clear association between topics and labels, which may suggest that the labels may not be related to specific keywords as assumed. Alternatively, this might be considered as evidence for data quality issues if the expectation is to have some correlation between labels and the associated commentaries. In this work, we incorporate LDA into the classification of financial time series data into classes of commentaries. Our analysis shows that LDA in combination with feature selection leads to improved results. Moreover, automated identification of class labels from commentaries enables experimenting with different numbers of class labels, which further improves the predictive performance. No significant correlation is observed between analyst labels and LDA topics. Future work includes acquiring more data to test out our approaches, as well as employing an active learning mechanism to guide the expert in manually labeling the instances so that number of manually labeled instances and the associated errors will be reduced. Thank you very much.